morning, students. We will continue our discussion for instruction execution. We will take a different example this time. Suppose our instruction is multiplication from Suppose this is our instruction. Okay. So what does this instruction means? We have to perform multiplication of these two locations, operands in these two locations, and we have to store the result in this memory location. So this is our source. This is our destination. Okay. So what happens is, suppose, I'm just supposing that in memory location 200 we have the value called 5, and at memory location 100 suppose we have the value called 12. Okay. So the result, that is the multiplication of this, will be stored where? At the memory location 500. So what is the result of this multiplication? 60, isn't it? So 60 will be stored back in memory location 500. Suppose our memory looks like this. Memory. And we have locations such as 200. This is our location. This is 100. And we have 500. So suppose at 200 we have 5. And here we have 12. So we have to perform the operation. The ALU will fetch the operands at which stage? The operand fetch, or we can say the decode stage. In the decode stage of execution, it has to fetch the operand based on the addressing mode. Here, what kind of addressing mode this is? This is absolute addressing mode, isn't it? This is absolute addressing mode. What happens in absolute addressing mode? I am giving you just a reminder that in absolute addressing mode, effective address is directly provided by the instruction. So whatever the instruction is, the effective address of the operand. What is effective address? Effective address is address of operand. So this is what address of operand is, isn't it? This is the address of operand. So this is effective address 1. This is effective address 2. Both these are, fetched by in the instruction fetch stage, and ALU performs the multiplication of these two operands and stores the result back in a memory destination called 500. At 500 the result is computed and stored back. Okay, so 60 is stored back here. So we will see how each and every stage performs. So what is the first stage? The first stage is instruction fetch, IF. What happens in instruction fetch? In instruction fetch, we have to fetch the entire operation, entire instruction. Fetches the entire instruction in IR. What is IR? Instruction register, isn't it? Entire instruction is stored in instruction register. So opcode, we have operand 1, operand 2, operand 3, isn't it? There are 3 operands. Okay. So what is the opcode here? Multiplication is the opcode here. That is the operation here. So after that we have instruction decode. What happens in instruction decode? We have to judge what is the addressing mode. Here in this particular case we have absolute addressing mode. So the processor needs to go to these memory locations, specified memory location, and it has to fetch the operand. That is what happens in instruction decode. 5 and 12 are fetched from memory location 100 and 200 respectively. Isn't it? This is what happens in instruction decode. Then we have execution phase. In execution phase, ALU simply performs multiplication. Okay. After that, in write back, what happens? In write back, the result of the multiplication is stored in memory location 500. Okay. So, result 60 is stored in memory location 500. So this is what happens, in totality with reference to this specified instruction. Okay, so I hope it is very much clear to you now. Now remember, always, as we discussed, both these stages combined are called fetch cycle, and these two stages combined together is called execution cycle. Okay, I hope it is crystal clear to you now. So with reference to multiple, instruction, we can always generalize this, because all these stages perform specific operation depending on the type of instruction. Instruction fetch always fetches the instruction into IR. Instruction decode fetches the operand. Okay, it gets the operand based on the addressing mode specified, and execution always depends upon the opcode specified. If the opcode is multiplication, the ALU performs multiplication. If the opcode is modular operation, then the ALU performs mod operation. Okay, and in the write back, what happens? The result is stored back into the desired location. Whatever location is specified as the destination, there we have to perform the operation and store the result back. Okay, so this is what happens in instruction execution. Okay, in the next class we will continue our discussion with the next topic. Okay, in the next class we will discuss about various control called hardware control and microprogram control, in which these are two types of performing operations based on the underlying architecture. It may be hardwired architecture or it may be programmed architecture. So based on this, we have two types of controls called hardwired control and microprogram control. We will continue the discussion with these two topics in the next class. Okay.